So the previous period when we were here, everyone watching, we looked at we did some reflection, and there was 4 questions. And if you feel comfortable enough, you can write the answers to your questions. You can label them question number 1, 2, 3. And if you are comfortable enough, you can write them down in the comment section down below. So today, that was now a reflection, but today we're going to continue and we're going to look at the memorandum discussion. Now, when we're talking about a memorandum, this is the expectation of how you were supposed to answer these questions. Looking at question number 1, they say there, write down the following, the first 4 multiples of 7. Right now, there was a slight deviation, and I tend to sometimes, because I understand how learners think, or I think for them, and sometimes when you don't even include for me the full answer, I will still give you half a mark. It's not really half a mark, but I'm generous in that way. And so if we talk about, I'm just going to write so that everyone can see. I want you to write with me. There, after that last 4 questions, you write today's date and then memorandum discussion of this was the examination, June examination of June. All right. So the first question there, as we said now, question number 1.1 was the first 4 multiples of 7. Sorry? Yes, the first 4 multiples of 7. So question number 1.1, what is the first multiple of 7? It's 7 himself. Right? Then after 7, if I add another 7, that's what multiples mean. If I add another 7 there, it's going to be 14. And then if I add another 7, it's going to be 21. And if I add another 7, it's going to be 28. All right? And that is, all of those together is your 1 mark. And that's easy points that you were supposed to score there. Question number 1.2. They ask us here 2 factors of 30 that have a sum of 11. Now, this you had to read here carefully. They say, now let's quickly I'm not going to answer, but I'm going to do my thinking process to the side here. So I'm thinking a little bit. I call this my thinking process. All right, I'm going to scribble here to the side. I hope you can see my thinking process. This is not my final answer. But if I think about the factors of 30. What is a factor of something? A factor is anything that's divisible through something else without a remainder. So I'm going to take all of the numbers smaller than 30, and then I'm going to divide them and see if there's a remainder. If there's a remainder, it's not going to be a factor. So the first factor will always be 1. The next factor will be 2. The other factor will be 3. Is 4 a factor? No. Why is 4 not a factor? 4 is not divisible by 30 because there will be a remainder. All right, so what is the next factor then? 5 and 6 and 10 and 15 and 30. Now that is all the factors of 30. But they ask me for specific factors. They ask me for factors that have a sum. Now, if I hear the word sum, what am I supposed to know? It's a plus sign. Are you following my thinking? So I'm thinking about the question. Some of us just answer the question without even thinking about the question. It's important to everyone watching that you always arrive at the question. And many of us left this question open unnecessarily. It is not a difficult question. It was just a thinking question. But we are lazy to think sometimes. So the question reads, the 2 factors of 30. Right? There's more than 2 factors, but they're looking for 2 specific factors. If I add them together, I get 11. So that factors must be 5 and 6. Or it can be 1 and 10. But the memo answer here was 5 and 6. Moving on now to question number 1.1.3. They ask us the third power root of 125. Third power root is actually another word for the cubic root of 125. Now in term 1, we did a lot of emphasis on something that we call prime factorization. Do you know, can you recall prime factorization? And we're going to do it later as well. So I'm not going to do the prime factorization step here, but I'm just going to show you that you could have done this without the calculator. Because if you do go prime factorize, we're going to write the prime factor 125 in its prime factors is 5 to the power of 3. Now to get rid of the surd or the root, I take the base and I divide the exponent by the index that's outside. So if I want to get rid of this, I basically say it's 5 to the power of 3, divide by 3, divide by 3. How many times does 3 go into himself? Once. So that's actually 5 to the power of 1, and that's how I got 5. You didn't have to show all of those steps, but I'm just showing you how you could have done it as well. Now they ask you the addition versus of negative 5. So they're talking about addition. So we should add. And if we add, so they're talking about addition inverses basically. If I add something, I'm supposed to get 0. Negative 5 plus what gives me 0? Plus 5. So my answer there is 5 or plus 5. That plus wasn't necessary, but your answer there is 5. Going on now to 1.2. 1.2 asks us, write down all the factors of 36. I like to write F 36, and then I'm going to write the factors of 36, which is, I know 1 is always a factor. Is 2 a factor? Yes. Is 3 a factor? Yes. Is 4 a factor? Yes. Is 5 a factor? No. Is 6 a factor? Yes. 6 is actually a factor that goes with himself. All right. Now, once I'm in the factors that goes with himself, it's easy to check this because now I just need to find the pair that goes with him. All right. So, what is the number that, let's say, 36 divided by 4? What is the answer going to be? 12. 36 divided by 3? Sorry. What is 36 divided by? No, I still have some more factors. Let me just see. 36 goes in himself. What is 36 divided by 4? Yes, 12, no? It's first 9. Yeah, sorry. And then it's 12. And then it's 18, the half, and then it's 36. How do I check? I check this times that one. 1 times 36 is equals to 36. 2 times 18 is equals to 36. 3 times 12 equals to 36. 4 times 9 and 6 times himself is equals to 36. Everyone still good with that? Moving on now to question number 1.2.2. Determine the lowest common multiple of 24 and 32. Show all the steps. All right. So there's numerous ways how you could have done this. In grade 9, the expectation is for you to use the common, the principle. Now this is on the other video. If you're smart enough, you can follow that. You should try to find that video because I shared it with you last term when we were also doing the memorandum discussion. All right. So what you should do is you should write down the factors of 24 and also the factors of 36, the prime factors. All right. So Does anyone have the prime factors of these numbers? 2 and it's going to be 2 to the power of 3 times, that's 8 times 3. Alright, and then of 36 is probably going to be, is it 32? Sorry, let me correct that then. Right, so of 32, let me just correct this. It's 2 to the power of 5. Now, there is another way that we did in previous years. They are looking for the lowest common multiple, LCM. No? So all that you do, you take all of the numbers and you multiply them together, but then you only take the highest exponent. So in this case, it will be 2 to the power of 5 times 3. Alright, so that's basically 32 times 3, and your answer is going to be 96. That is a quick way of doing it. No? The longer way, alternatively, I'm going to try and do it next to it. It's going to say, alright, now we write down the multiples of 24. So it's going to be 24, then 48. What is the next one after 48? 72, and then 96. If we add another 24 to that, 120. If we add another 24 to that, 144. And so we can continue with that pattern, all right? And then now we need to do the multiples of 32. So the multiples of 32 is going to be 32, then 64, and then 96. And then if I add another 32, it will be 120, 128. If I add another 32, 160. All right, so we can continue there with this pattern, and it's easy with this one, but sometimes you will see, so the numbers that are the same, it's just 96 here, and that's why 96 is the lowest common multiple. But remember, this is actually the long way, and you are taught this in grade 8. And when the numbers are bigger, this number, that 24 and 32, is not so big. But when the number gets bigger, it's more difficult to identify what is the LCM. All right? What is the enlighten me with that? All right, now I'm moving on to question number 1.2.3. Now they ask me for the greatest common factor of 56. Now, I truly can recall myself, and it feels almost like deja vu. I think it was also a rainy day like today, where I told a secret to one of the learners in this class. And the secret is, when we are determining the highest common factor, or they call it here the greatest common factor, all you have to do is you take the factors that are the same, but we use the lowest exponent. So in this case, what is the same of the factors? 2. No? 2 is the same. So the greatest common factor, but what is the between? There's 2 to the power of 3 in the one, and there's 2 to the power of 5 in the other one. Do you see there? 2 to the power of 3 there, and 2 to the power of 5 there. Because there it appears and here it appears. So 2 is the same. But what is the lowest between them? What is the lowest exponent? 2 to the power of 3. So therefore, we're going to say the greatest common factor, or HCF, and I like to put it between brackets the number 56 and 72 is going to be 2 to the power of 3. Now, if I work out this, it's going to be 2 times 2 times 2, so that equals to 8. And that's our answer there for 1.2.3. Moving on now, and this got me very furious when I was marking, because I believe that all grade 9 learners have been doing fractions since grade 4. Alright, so they ask us, write this as a decimal fraction. And we know the decimal fraction consists of a binomial system, which consists out of a 1 and a 0. Alright, so all we need to do is get the denominator to either 10, 100, or 1,000, a type of number that has 1 followed by zeros. So how do we get 5 to, what is the closest? We multiply by 2. So we just had to multiply this by 2 over 2. Now why am I multiplying by 2 over 2? Because 2 over 2 is equals to 1. And this equals to 4 over 10. Now once it's like that, I can rewrite this as 0, 4. I don't even want to mention here what some of the learners write. No? So I'm not going to play the blaming game here. So that's just following there. Let's finish now with question number 1.3. Right, so they ask us to write 1,386 as prime factors, as a product of its prime factors at 1.3. And I would prefer that you would have done this way. You take that, you ask what is the smallest prime number that can devise by that this can devise into. So that's 2. 2 goes into 13. How many times? That's good work. 6 times. There's a 1 that remains there. 13, 2 goes into 8. How many times? 18. 9 times, and it goes into 6. 3 times. What is the next number that can go into that? 3. Alright, let's try 3. Because 2 can't go into that, so it's going to be 2, 3, 1. What is the number that can go into that? 3 again. Are you sure? How many times? Mr. Garland. It's not a new teacher, just hold on. So here we see that the 1,386 written at its prime factors can be written as 2 times 3 to the power of 2 times 7 times 11. And that's question 1 for you guys. Moving on to question number 2, I'm first going to read the question and write down the important information for myself. So, what I have there at question number 2, I have there, it says that consider the expression, and I'm going to write the expression down for myself, which is negative 4x squared, and I want you guys to do the same, to the power of 4 plus 2 x squared minus 10x minus 8. And always do this in an exam. If you need to do if they are going to ask you questions about the expression, it's nice to write it down in your own handwriting. Otherwise, you forget what the question is about. Now, the whole question 2 is about this, basically. All right, so that's why I've been writing it, or that's why I'm asking you to write it down. Now, moving on to question number 2.1. they ask you now, how many terms are in the expression? And I'm going to make some notes in pencil for myself. I know that an expression is separated by a plus or a minus sign. So this is my first one. I'm just going to zoom in there for you so that you see. I'm going to count. This is number 1, this is number 2, and this is number 3, and that is number 4. So how many terms do I have there? 4 terms. Now many of you just wrote 4. I still gave you you were supposed to be specific, 4 terms, but I still gave you the mark there. Didn't want to penalize you unnecessarily. And then the next question asks us 2.2, the constant term. Now a constant term is a term that doesn't contain any variables. And let's look, the first term there has 4x, negative 4x to the power of 4. The second term is 2x squared. The next third term is negative 10x. And then the fourth term is negative 8. No variables there. So that must be the constant term. And some of you forgot to write for me negative 8. It's not just 8. Remember, the sign in front plays an integral part is to determining whether it is positive or negative. So you need to write down the sign in front as well. If it's positive, it doesn't have to be written down, but especially when it's negative. And in the most cases, they know you're going to forget, or you are sometimes lazy, so you don't want to write that down, and then you lose that mark unnecessary. Moving on now to question number 2.3, the degree of the expression. I can probably count how many of us got this right on my 10 fingers that I have, because the degree of an expression, now you can go back to the front of your notes, it was there. The degree of an expression is the highest exponent that we can see. And we are working here in terms of x. And the highest exponent is 4. So we could have said there 4, or to be more specific, it's to the 4th degree. That is your answer for question number 2.3. Then that was a spelling error there. They're supposed to be asking for the coefficient of the x squared term. What is the coefficient there? 2. So our coefficient is positive 2. Now they ask you the value of the expression if x is equals to negative 2. So that means everywhere in the expression, I'm going to substitute in the place of x, negative 2. So let's do that together. I'm going to need your help here. Okay. You could have done this with a calculator. I'm going to do it without a calculator. So that's going to be negative 4, negative 2 to the power of 4, plus 2 times with negative 2 squared, minus 10 times negative 2 minus 8. And my first step in anything like this is always to do first substitution. Now I'm going to follow the rules of BODMAS, which is I should first start with my brackets. If I have a negative 2 times with himself 4 times, what is the answer going to be? Positive 16. Alright, so there's still a negative 4 there, times with a positive 16. A negative 2 times with himself is equals to a positive 4. So that means it's plus 2 times with positive 4. And then we can do this one together because there's no exponent there, or the exponent is 1. So negative 10 times with a negative 2 is equals to a positive 20 and then a minus 8. Now, if I have a bracket like that, I know I should multiply that with the number that is in front of the bracket. So negative 4 times 16, well done. She says here it is negative 64. 2 times with 4 is equals to positive 8 plus 20 minus 8. Now, there's a reason why I didn't go subtract that 8, because if you look at this, they are actually terms which we call are they have the additive inverse property, which means the one side is a positive, the one side is a negative, so they cancel out. So I can basically just say it's negative 64 plus 20. And that answer is going to be negative 44. And there's your answer. As simple as that. I'm going to move on now to question number 3. I'm going to give you a minute to just copy that. Make sure you have that answers as is on the board. Please get it into your book. Question number 3, we have there a pattern consisting out of bricks. And each time there's something happening, right, to the pattern. Now, the first question there, 3.1, is how many baking were needed to make pattern 5 and 6? Who can tell me, who can give me some help with that one? Pattern 5. Pattern 6. How many bricks? How much are we adding each time? 4. Alright, so we're starting with 4, then in the next one we have 8, 12, and then 16. So the next one, pattern number, will have 20 bricks. The next one will be 24 bricks. The next question after that is 3.2. Determine the number of bricks in the 25th cartridge. So if this pattern continues, who can give me that answer? 100 bricks. 100 bricks will be needed for the 25th one. Then they say, which pattern in the sequence will require 276 bricks? Sorry, 267. So, was it right? 276 bricks. Yes? 69. That's absolutely correct. So we can say there, pattern 69 will have, 69. I struggle sometimes with ADHD. It's like ADHD, but just better. Thank you for those who got that one. The rest will get it tomorrow. Alright, question number 4. Simplify, show all editing. Now, I know some of you cheated on this question, but I nonetheless gave you the marks. I'm not going to do that again. Next time I want to see all of your working, okay? So there we have a square root. Under the square root I have 10 times 30, and then that's divided by 7 minus 4. So BODMAS tells us we should first do the brackets. And if we do the brackets, we're going to get 7 minus 4 is equals to, great stuff, 3. No? So there we have 10 times 30. What is 10 times 30? 300. So we have 300 divided by 3. Well done. And then 300 divided by 3 is equals to 100. So 100, the square root of 100 is equals to 10. So your answer there is 10. Now some of you went straight to 10. That is technically wrong. I'm not supposed to give you all of the marks. Okay? I'm supposed to mark it like this. For the first step there, second step there, and then for the final answer. But I know you use the calculator. But next time, just remember that, because I will penalize you and have now informed you. And the instruction was not clear by saying you cannot use a calculator. But next time I will make sure that the instruction is clear. So this is actually how it's supposed to be done. And then question number 4.2 looks like this. We have the 4.2. It's 2 to the power of 3. So that means 2 multiplied with himself 3 times. Plus 3 to the power of 0. Anything to the power of 0 is equals to 1. Then I have, so I'm going to simplify. 2 times with himself twice is equals to 4. Times another 2 is equals to 8. So that's 8 plus 1 minus 5. 8 plus 1 is 9. Minus 5 equals to 4. Am I going too fast for you guys? This is grade 1 work, man. Why are we going so slow? Please make sure you show your calculations there. And then the last one at 4.3. Question number 3 was actually the best answered question according to my markings in the 2 classes that I marked of grade 9 classes. Alright, here we have negative 3 to the power of 3 within a bracket plus 22. So that is negative 27. Thank you for that. So that answer is negative 27 plus 22, which equates to, difference between that is negative 5, yes. There's your answer. 2 marks for that one. Yeah. Okay, almost done there. We're moving on now. I like this space. Is everyone done? Okay, going on to question number 5. Please make sure you understand this work. Watch this video over and over until you do understand it. And comment if it's not your first time watching the video, but if you're making a turnaround studying for the end of the year exams as well. Alright, now once again they say this seems quite familiar. It seems almost very similar to the question they had in question number 2. Consider the expression. I'm going to write down the expression there for myself. Negative 23x to the power of 3 plus 11x minus 13 minus 3x squared. Once again, they ask us at 5.1.1, how many terms do this expression consist out of? Once again, we can count. It's 1, 2, 3, 4 terms. It's almost like a school year. Someone is out when they come back, you can count. Where you only now halfway to the grade 9 year. Alright, 5.1.2 is write down the constant term. Who can tell me what is the constant term there? Negative 13. Now, a lot of you wrote 13. Once again, you're throwing away that marks unnecessary. Write down the coefficient of x to the power of 2. Coefficient of x to the power of 2 is going to be negative 3. Is correct. This one is a nice one. I don't recall many learners getting this one right. They ask us, write the expression in declining powers of x, or descending. So that means we should start with the highest power, come down to the lowest. So what is the highest power there? It's the third one. It's the one that has x to the power of 3. So that's the one is first, negative 23x to the power of 3. And then the next one is going to be negative 3x squared. Which one is next? Plus 11x, and then the last one is going to be the constant term, which is negative 13. Also easy marks that we threw away there. 5.1.2, sorry, 5.1.5, they give us again x is equals to negative 2. We're going to substitute into this equation. So that's going to be negative 23 negative 2 to the power of 3 minus 3 times negative 2 squared plus 11 negative 2 minus 13. Right, help me here. I'm first going to do the bracket, so that's going to be negative 23 times with negative 8. Then this one is going to be negative 3 times with the bracket is going to become positive 4. And then it's going to be plus 11 times negative 2 is equals to negative 22 and then minus 13. Didn't get rid of all my brackets yet, so let's go do that now. What is 23 times 8? Two, 8, 4. That's good. Positive 2. No? Is it? 224. Yes. It's 224 positive. Let's just finish this one, guys. It's positive 224. And then it's going to be minus 12 minus 22 minus 13. And then our final answer is going to be 16. What is the answer? 170? 77? 177? Yes. Alright, 177. And that's where we conclude for now. Later we will continue with this. I thank you, everyone. Question number 6. The instruction here now is to simplify. And a lot of the times learners make the mistake that they do not simplify fully or simplify completely. So what we're going to do now, we're going to write down the questions first, and then just I want you to follow and write with me. So the first question says, and remember what is our instruction here? We need to simplify. 5a plus 3b minus 2c plus 4a minus 7b minus 4c. Now, what I like to do, and I would suggest you do the same, is you go write the like terms together. So I can identify 5a, and then another like term that goes with 5a is going to be plus 4a. And then what goes with there, it's the only terms consisting out of an a. Then we have 3b, and then we have minus 7b that goes with him, and also we're going to have negative 2c and minus 4c. Now, like terms, only the coefficients are going to change, but the variable remains the same. So I'm going to ask myself, what is 5 plus 4? That equals to 9. 9 of what? 9 of a. And then 3 minus 7, that equals to negative 4b. And then minus 2 minus 4 is equals to negative 6c. So that's my first answer there for 6.1 that needs to be simplified. Moving on now to question number 6.2. 6.2 looks like this. We have the within a bracket. Sorry, it's not within a bracket. Let me just correct that there. So we have the, yes, within a bracket, negative 3 n to the power of 4, and that whole term is to the power of 3. So this is now going to be the answer. I can just write down the answer immediately, which is going to equate to negative 27 n 4 times 3, and that gives me an answer of negative 27 n to the power of, what is 4 times 3 is 12. This is the power to power rule that we are incorporating here. So my final answer is the negative 27 n to the power of 12. Next one is 6.3 question, and the instruction remains the same. I need to simplify. So I can simplify now 56 p to the power of 8 q to the power of 7 divide by negative 4 p to the power of 3 and q to the power of 4. Because we're doing division, it's a positive divide by a negative, so that's going to be a negative answer. So we know our answer is going to be negative. Now I ask myself 56 divided by 4, and that equates to 14. So that's going to be negative 14. And now it's fairly simple. When I'm doing division and my bases are the same, I can simply just say it's p to the power of 8 divided by p to the power of 3. So I'm basically doing subtraction of my exponents. And then we are going to have q to the power of 7 minus the 4. Only because my bases are the same, I simplify this. So that's going to be negative 14 p to the power of 5 and q to the power of 3. And that's our final answer right there. Moving on to question number 6.4. We have the negative 2x to the power of 4, y to the power of 6 times with negative 14x to the power of 5 y. Right, it's a negative times with a negative, which equates to a positive, and 2 times 14 is equals to coefficients are multiplied with each other, so that's equals to 28. Then x to the power of 4 and multiplied with x to the power of 5. That means I'm going to write it out. My bases are the same, so that's x to the power of 4 plus the 5 there, and then y to the power of 6 plus that 1. Many of the learners forgot that, so please look out for that mistake. Don't make it again. That's x to the power of 9 and y to the power of 7 that we have there. Moving on now to question number 6.5. At question number 6.5, we have the really straightforward one, but we need to apply the rules of BODMAS here. So that's 3x to the power of 2 within a bracket. So I first need to do the bracket first. So that's going to be negative 2 that stays outside. If I do the bracket, that's going to be 3 squared, which equals to 9, and x squared is equals to x squared. So now I'm going to multiply that out. So my answer is going to be negative 18x to the power of 2. And there's your final answer for that. All right. That's nice work. You're just briefly going over all of the answers of question number 6. Take a minute, glance at it. If you got all of them right, write your name down in the comment section down below. Thank you for doing that. Moving on now to question number 7. All right. Question number 7, nice algebraic question here that we have. Building on that, the first question number 6 was to simplify. At this question now, and always make use of a ruler when you are working with this. So use your ruler, draw the line, make your work presentable, nice and neat for the examiners to see. Otherwise, by doing that, you also create a good perception of yourself without the examiner seeing you. All right, so the question reads as solve for x in each of the following equations. And then we have there question number 1. We have 3x plus 7 is equals to 25. Now, how we can do this is mainly by inverse operations. So first thing that we're going to do is we're going to take the 7 over. If the 7 goes over, it's going to be 25 minus 7 because it was plus 7 on the one side. So 25 minus 7. All right, now we're going to simplify that. 25 minus 7 is equals to, I think it's 18. So that's 3x is equals to 18. But now I know that's 3x means it's multiplication. So on both sides, I'm going to divide by 3. So that becomes x is equals to 18 divided by 3. And 18 divided by 3 is equals to 6. So x is equals to 6. That's our first one there. I'm going to do my second one just next to it. Second one looks like this. So we have 7.2 there. It says 7x minus 13 is equals to 5x minus 19. What we can do is take all of our variables to the one side and take all our constants to the other side. This is the easiest to do. So that's going to be 7x. I bring the 5 over, it becomes negative 5x. And then I take the 13 over, it becomes negative 19 plus 13. 7x minus 5x, like terms, is going to be 2x. And then negative 19 plus 13, the difference there is negative 6. Once again, here we have 2x is equals to negative 6, but I don't want to solve for 2x, I want to solve for x, so I need to get rid of the 2 that's in front of the x, and now I know that that 2 actually indicates to me that this is multiplication, so it's 2 times x. So now I need to say x divided by 2 on both sides, so that's going to be negative 6 divided by 2, and then x is therefore equals to negative 3. And there's our answer for that one. Moving on now, we have 7.3, where we see our question is negative 2 bracket x minus 3 and then is equals to negative 8. All right, now there's numerous ways how you could have, there's a few ways how you could have done this one, but I would prefer to expand the bracket first. So I'm going to say negative 2x, and then I'm also needing, don't forget to multiply that negative 2 with the negative 3 inside, which equals to positive 6 is equals to negative 8. All right, so what was the first step there? The first step was to expand the negative 2 in front with the terms that is inside of the bracket. Now, what I'm going to do next is I'm going to say negative. I'm going to leave the negative 2x on this side, and then I'm going to say negative 8. I'm going to take the 6 over to the other side, so that becomes negative 6 on that side. All right, now that answer there is x to negative 2x is equals to negative 14. I need to divide here on both sides by negative 2x to get x alone, so that's going to be x is equals to negative 14 over negative 2. And that means my answer for that one is going to be x is equals to positive 7. Indeed, your answer is correct. All right, so there is your whole, all of your whole of question 7, also the whole of the questions that we did last term for the examination. This is always going to be a good reference for you to work from when you're doing algebra. For this term, we're going to start now with functions and their relations, and we're going to see how we can correlate that to what we have left. So let's start and go to the current notes that we have about functions and relationships.